All right, we're still looking at operations of functions because we're still in learning target 2. But instead of looking at addition, subtraction, multiplication, and division, we're looking at function composition. Okay, it's kind of an operation that's unique to functions. So we're going to spend one entire lesson just looking at composition. All right. So here's the idea with a composition of functions. Essentially what you do is you use an output of a function and it becomes the new input for another. Here's the notation, all right? I tend to like the second part right here. So we've got our function f. If we want to compose it with another function g, okay, what we do here is we say f of g of x, okay? And that output or y value that I get from g, that's what gets substituted into x for function f. Okay, we would call this a composition of functions f and g. Okay, let's take a look at some examples. Okay, so we got two functions here, f and g. All right, first one, f of 2. Okay, that's using the function x minus 4. That's just 2 minus 4. That's negative 2. Nothing too fancy there. This is just regular evaluation of functions. G of negative 5, that would use this function up here. 2 times negative 5 is negative 10, plus 2 is negative 8. Okay, and here we see a composition of f and g. F of g of 4. Okay, what this is saying is I'm going to first find g of 4. Okay, I'm going to first find g of 4, and I'm going to use whatever that is as the input for f. Okay, well, g of 4, from plugging 10 into, again, this function right here, that's 10. Because 2 times 4 is 8, plus 2 is 10. So now I'm going to evaluate f of 10. Okay, the output from g of 4, that's what goes into f. Okay, and f of 10 is 6. So I could have said from the beginning that f of g of 4, that would equal 6. Okay, we can do function composition with variables. Okay, the function f is x minus 4, okay? But now I'm going to take this function g and plug that in for x. Okay, so x is gone, and what I'm going to substitute in for x would be 2x plus 2, okay? There's nothing to distribute on those parentheses, so I can just drop them. 2x plus 2 minus 4 ends up being 2x minus 2. Okay? That would be that new function, which would be equal to f of g of x. Okay? What if I do it the opposite way? What if instead I do g of f? Okay? Here's the function g, that's 2x plus 2, but notice I have not put in x because instead I'm going to replace x with x minus 4. Okay? Then I'll simplify here, getting 2x minus 8. Simplifying from there, I get 2x minus 6. Okay? One important thing to take a look at here is this very important point that f of g of x, in this case, does not equal g of f of x. If you compose two functions in the opposite manner as these two have, many, many times the two functions that you get as a result, here it's a linear function, 2x minus 2, is not the same. Okay? Is not the same if you reverse the order of the composition. Okay. So what if we compose it with 3 different functions? Can you do this? Well, sure you can. Okay, the key is just to start on the inside and work your way out. For example, on this first one, what I really need to start with is what is c of 2? Okay, well, here's function c. If I put in 2 for x, 3 times 2 plus 6 is 8. Okay, now I'm moving out. And because I'm plugging c of 2 in for b, I would like to know, well, what is b of 8? Well, here's function b. That would be 8 plus 3 over 2. Get a fraction. Okay, and finally, what is c of 11 over 2? Plugging that in for x. Whoops, excuse me. I'm not plugging that into function c. I am plugging that into function a. Okay, a of 11 over 2 ends up being 8. So a of b of c of 2 is 8. All right? Again, I can't stress enough. Start on the inside, work your way out. All right, let's take a look at this one right here. First thing I need to find is what is a of negative 4, because whatever that is, I'm going to plug it into c, and then whatever that answer is, I'm going to plug that in for b. A of negative 4, after having seen one of these, this isn't a bad point to pause and see if you could work through this on your own. I'm going to do it in a second, so if you want to pause now, you can work through it yourself, and then I'll go through the answer here in a second. A of negative 4 is negative 11, so that's what goes in for C. C of negative 11 is negative 31. B of negative 31 ends up being negative 14. Okay, so B of C of A of negative 4 equals negative 14. Okay. Oh, look at this last one. Triple composition with a variable. Let's give it a shot. Okay, start on the inside and work your way out. All right, so I'm starting with function C. Okay, I'm going to kind of just make sure this one is clearly set apart from all the others. Don't want to get the work confused. Okay, I'm going to scroll up here just a bit so I can give myself a little bit more space. Okay. C is 3x plus 2. Okay, now that needs to go in for x into function A. Okay, so I'm going to take C of x, I'm going to multiply that by 2, and then subtract 3. Okay, well, that whole thing has to go into B, so I got to put parentheses around this, add 3, and then divide by 2. Okay, seems miserable, but it's not so bad. Okay, let's actually go through and simplify this. All right, I got to distribute here, because the big thing I want to do now is to make sure this is simplified. Okay, so up on the top I would have 6x plus 4 minus 3 plus 3. Okay. The minus 3 and plus 3, those are just going to cancel out, leaving us with 6x plus 4 over 2, okay, which would lead us to 3x plus 2. And again, this is B, compose A, compose C of x. Okay, so instead of going through these 3 different steps like I had to do up here, like on this one, might be worth my time if I want to do a composition to just get the function in terms of a variable. Okay, and now if I wanted to find, for example, B of A of C of 4, I could just plug 4 straight into this, okay, because I already factored in all the composition. All right, these I'll just kind of talk through here. Really, if you want, these would be good practice on your own. You can go through these. What I just want to emphasize here is that you're doing 2 different compositions, B of A and A of B. Okay, on one of them you're going to show that they are the same thing. Okay, and that sometimes that happens. The composition of 2 functions, regardless of which order you do it in, sometimes they're the same, sometimes they're not. Okay, we actually already showed a case in the first examples with F and G, where that when we reverse the composition that they weren't the same. Okay, you would treat these cases individually. First find that, then find this. The key is fully simplify them, show that they end up being the same thing. Okay, just as far as a hint to work through on this one, when you do both of these, you should see they both simplify to X. Okay, then do A compose C and C compose A, and you'll see that they don't end up being the same thing. Okay, good ones to try on your own. If you get stuck on those, let's take a look at that in class and we'll talk more. All right, we'll see you then.